Hi, my name is Elizabeth Heiser. I'm the Euclid Creek Watershed Program Manager, and I'm excited to share with you today about our volunteer water quality monitoring program. So we're going to talk a little bit about who I work for, Cuyahoga Soil and Water Conservation District, a little bit about the Euclid Creek Watershed that I'm the coordinator of, and then we'll talk about our monitoring programs, what we do, why we do it, and then a little bit of how we look at the data and how we are using this chemistry data in our watershed programs. So Cuyahoga Soil and Water Conservation District has been around since the late 40s. Our mission is to implement programs and practices that protect and restore healthy soil and water resources. Here in Cuyahoga County, we're dealing mostly with stormwater issues and urban runoff. So lots of pavement, moving water fast, picking up pollutants, and how we address that as watershed coordinators, as inspectors, and as educators. So most people probably don't know what soil and water conservation districts are. We stem way back from the Dust Bowl in the 30s. So once we were losing so much soil, they decided to start soil conservation service districts. And every county in Ohio now has a soil and water conservation district. And we all focus on protecting soil, protecting water resources, and how how communities can work to conserve soil and water. So as part of that, in Cuyahoga Soil and Water Conservation District, we have 3 watershed coordinator positions. My position, which focuses on the Euclid Creek watershed. We have Jared Bartley, who focuses on the Rocky River watershed, and we have a 3rd watershed coordinator that works on our Cahoon and Porter and Spencer Creek watersheds that are direct Lake Erie tributaries on the west side of the county. So the Euclid Creek Watershed Program is really special in that it was a pilot program for when we started to get rules and regulations for stormwater runoff. And so mayors from 9 of the 12 communities that drained the Euclid Creek watershed got together and formed the Euclid Creek Watershed Council. And the council meets 3 times a year to talk about things that we can do in the Euclid Creek watershed to help address stormwater runoff problems, flooding problems, erosion, and they do that collaboratively. So we have 9 mayors or their representatives that get together with the watershed coordinator, and we meet to talk about our education programs, about our about development projects and how we can use best management practices. And then we also have our committee for what we're going to talk about today, the volunteer monitoring program. In addition to our Euclid Creek Watershed Council, which is one arm of our Euclid Creek Watershed Program, we also have Friends of Euclid Creek. They are our volunteer organization. Their mission is to be the voice for the creek. They do a lot of educational programs. They do a lot of fundraisers for conserving special properties in the watershed. And they really do get together monthly to meet and talk about issues in the watershed and how we as citizens can help. And then Cuyahoga Soil and Water Conservation District houses the Euclid Creek Watershed Coordinator position. So way back in 2002, 2003, when the Euclid Creek Watershed Council was starting, there was a grant from the Ohio Department of Agriculture that supported watershed coordinator positions. And basically our job is to help write plans and implement plans for protecting watersheds and providing good water quality. So the Euclid Creek watershed, if you're not familiar with it, is on the east side of Cleveland. So you can see the area in yellow on this map is what we call the watershed. If you don't know what a watershed is, you can consider that basically all of the land that drains to one same water body. So in our case, in Northeast Ohio, we all live in the Lake Erie watershed. Everything is flowing north towards the lake. And in Euclid Creek, all of the water in that yellow area of all these communities, Cleveland, Euclid, Richmond Heights, South Euclid, Lyndhurst, Highland Heights, Willoughby Hills, Mayfield Village, Mayfield Heights, Beechwood, and small little area of Pepper Pike, all of those little yellow areas in those communities drain to either a tributary or the main stem of Euclid Creek. So there's 34 miles of above ground streams, 24 square miles total that drains to the same place at the mouth of Euclid Creek, which if you can get down to Wildwood Reservation, it's a great park. That's where Euclid Creek meets Lake Erie. We're very densely populated watershed, mostly residential, over 50%. not much undeveloped, about 14%. We're very fortunate to have Cleveland Metro Parks in our watershed. We have Acacia, Wildwood, and Euclid Creek Reservation, which are all really great protected places, good places to get in and see the creek. But we have a lot of development, and so we've got our work cut out for us in protecting water quality in Euclid Creek. So for our volunteer monitoring program, this started way back in 2006, and we had many partners involved with getting our volunteer water quality monitoring program up and running. And these are just a few of them, but until recently, we always had a partnership with a college, so either Tri-C or John Carroll University or Notre Dame. All of them helped with Ohio EPA, with our Watershed Council, to put this whole program together and meet some goals for water quality monitoring. So why do we sample? Why are we sending volunteers out to the creek? Our main goal with volunteer water quality monitoring is to engage stewards and to engage people with the water that they live in and around. And so, you know, citizen science, so getting people out in the creek, getting them sampling, and getting them to understand how the things that we do on the land affect the water quality. And obviously this is important. All of the water from Euclid Creek ends up in Lake Erie, and Lake Erie is where we get our drinking water from. So we're really working to work with citizens that are maybe just interested in what their local water quality is, and teach them a little bit about it through citizen science. In addition to that, we do have programmatic goals for this water quality data, especially with Euclid Creek. We have what's called a total maximum daily load for the watershed. So back in 2005, the state of Ohio worked with a consultant to determine load allocations or allocations for pollutants of what could be in Euclid Creek and still be considered healthy. And so we have parameters set for phosphorus and for nitrogen that say, you know, when you're above this bar, the creek will not be meeting their water quality standards. So we can use this citizen science data to help us see if we're getting close to meeting those TMDL goals. We can also use data to identify trends, look at if any pollutants are of specific concern, what are potential causes of impairment based on which pollutants we're seeing that are high. This allows us to look at our existing sources, our existing land use, and compare that to water quality standards and see what we can do to perhaps improve. So I'm going to talk a little bit about the different parameters that we go out and sample in Euclid Creek and why we look at them. The first is turbidity or suspended solids or total dissolved solids. So basically with all of these different tests, what we're looking for is how clear is the water? Is there a lot of sediment in the water like this photo on the right, or is it really clear? Typically in Euclid Creek, it's pretty clear. Because we're so urbanized, we don't have a lot of erosion and specific sites draining off. So when we see a lot of sediment in the creek, that means that it probably just rained and we're getting erosion, or maybe there's a construction site that's not being protected and sediment's getting off the site. This is really important to look at because fish and macroinvertebrates can't survive if there's too much sediment in the water column. It starts to clog out their breathing capabilities, clogs places that they can breed and feed. And so it's really important for water quality that there's not too much sediment in the water column. Next, we look at nitrogen. Specifically in Euclid Creek, we test for ammonia, and that was decided because ammonia is a driving factor for if fish are going to have issues. And so when we start to see that ammonia creep up, that can cause fish kills. But there's all different kinds of nitrogen that we could be looking at. So for example, in Rocky River, they test for nitrate nitrite because they have a lot of wastewater treatment plants in that watershed. And so typically when they're treating our wastewater, you'll see that nitrate nitrate coming out of the wastewater treatment plant being higher than what we want to see in the stream. You can also have all these different nitrogen parameters that we could look at, but those are the two that we specifically test for at Cuyahoga Soil and Water with our volunteer monitoring programs. Nitrogen is an important nutrient. It's natural for it to be in the water, and in coastal waters, it's when it gets out of balance, that's when you'll start to see algae growth in coastal waters. And so with that, we're talking about like red tide. So that's not the driving factor for our algae blooms that we see here in Lake Erie. Nitrogen cycle is affected by pH and temperature. So all of these parameters work with other water quality parameters and can impact how the health is. So the next thing we look at is phosphate. So we're looking for phosphorus. And that is because phosphorus in Euclid Creek has historically been high. It's still high. When we get too much phosphorus in our freshwater systems, that's when we start to see algae blooms, like in Lake Erie, like when they shut down the Toledo water plant. So just like nitrogen, it's an important thing to have. It helps plant growth, and so if we get too much of it, that's when plant growth gets out of whack. Total phosphorus binds to soil, and so you know, we can see a lot of phosphorus runoff from agricultural fields. If they've applied too much, that does attach to the soil. You see erosion gets into the creeks, and so you know, phosphorus is a known issue, not just locally, but also in our agricultural watersheds on the western side of the state. The next parameter we look at is dissolved oxygen. So this is basically how much oxygen is available in the water column. And we look at this because when it gets too low, we know that we're going to start to see issues with fish. And so fish need a certain level of dissolved oxygen in the water to be able to survive. So we want to watch that and make sure that we're getting what we need for fish. Next, we look at pH. You know, we have different levels of pH that are good for healthy fish, healthy insects and bugs in our water column. And so, you know, we're just testing to make sure that's not out of the range that we would normally see. Next, and this one's really starting to be more of an important thing to look at, is we look at conductivity, and more recently we're also specifically testing for salinity. And so this is going to reveal basically how many dissolved materials in the water, from like salt applications, sodium chloride. You can learn a lot more about this, but basically testing is starting to show that our freshwater streams aren't fully recovering from after our winter salt application. So if you want to check out the link at the bottom here to greatlakessnow.org, basically salt is not completely dissolving out of our freshwater systems. So we really need to think about how we're applying salt and how it's impacting our freshwater streams, because once we get over a certain level, that's not healthy for the fish. It's also getting into our drinking water systems, which aren't designed to treat for that. So there's all kinds of health repercussions, not just for the environment, but also for us if we don't get salt under control. So in Euclid Creek, we have some specific targets from our TMDL that we talked about, that total maximum daily load. So we can look at these parameters and the data from our water quality monitors and semi-compare them to our targets. So these are our government targets. This is what the government says Euclid Creek needs to meet to be healthy for water quality for chemistry. And so our target for phosphorus is total phosphorus, and we have a target for nitrate and nitrate. And these nutrients in general are hard to set targets for. It's very location dependent. They've had a hard time deciding what different watersheds should target. So the fact that Euclid Creek has a nutrient TMDL is actually kind of unique for Ohio. A lot of our watersheds do not have nutrient TMDLs because we don't have standardized targets statewide for nutrients. Ohio is a really unique state in that most of its targets, especially for aquatic life use, are actually based on what they find living in the water. And so these chemistry targets are in addition to that. But you'll see with Euclid Creek that we're not in attainment for healthy fish or bugs, and chemistry is part of that. So it's just one piece of the puzzle. But there are other pieces that the state looks at, which is really good, because the whole point of aquatic life use standards is that we want to have healthy fish and healthy insect populations in our streams and in our watersheds. So with that, I'm going to talk a little bit about the monitoring program and the data that we take. So like I said, this program started in 2006. We've had monitors going out to 7 different sites since 2006 all the way through now. And they go out and in the past have had these paper forms. They would put their information on there. They would say which site they were at, what day, if they took photos, make some observations, and then they would enter their chemistry parameters. And in the past, we've had volunteers or staff help to enter all this data. So we have a database of all this data in Excel where we're tracking data year to year and site to site. So typically our monitors go out once a month to the site that they've adopted. It's not always consistent. Sometimes they don't get out when it rains or when it's really cold. All of our sites in Euclid Creek, we sample from a bridge. And so it's pretty safe to go any time of year, but you know, sometimes you just don't want to go out when it's crummy. So that being said, all of our water quality data for our volunteer monitoring programs, this is just more like trend tracking. We're not able to, you know, unless they happen to go out and see something right after a rain event, we don't necessarily know what was going on in between those sampling events. So this is more of a general picture of the watershed. It's not designed to be used to have instantaneous, oh, I know everything about the watershed today. But we did have a graduate student this year go out, and so she went out, every time she went out, she sampled all 7 stations. She did this during dry weather and during wet weather, and I'm hoping to be able to share some of her results. She's working on her thesis right now with that, but that'll give us some really interesting information that's a little more cumulative for the whole watershed, and we're really excited to see that and share that with others. But in the meantime, I wanted to show you how we do take a look at this data and ways we can think about looking at it to see if we can notice any trends over time or over spatially within the watershed. And so this is a chart of the volunteer phosphorus monitoring data, and it's looking at it from the left side of the chart. We're looking at our most upstream stations. So we've got Acacia Reservation, the station's like right as the mall drains into the park. And then we've got moving downstream along our west branch. So Euclid Creek has a west branch, starts in Beechwood and drains down through South Euclid into Euclid, where it meets the east branch, which starts over at Mayfield Village and Willoughby Hills, and then takes a sharp turn west and ends up meeting up with the the west branch in Euclid at Euclid Creek Reservation before they combine together to be the main branch. So this left side of the chart up to the first orange arrow is our west branch sites or our west branch tributaries. And then we've got 2 east branch sites, and then our final site is down at Wildwood on the main branch. And so what we're trying to look at with this chart is, are there any trends from moving from upstream to downstream? So this bar chart shows our minimum and maximum on that long blue line. And then in between there, we've got our more typical results that we're seeing. So 25th to 75th percentile. And that little red dash in the middle is the median. So that's our most of the time, that's what we're seeing. And unfortunately, you know, Euclid Creek's a small little watershed, 24 square miles, not really seeing too many spatial trends other than maybe a general dilution effect as we move downstream and the stream gets bigger. But interestingly, Mary Ann, who did her study on this and was sampling all sites, did notice some interesting trends that I think, you know, once we get her data sets, we'll be able to look into in more detail. But generally here, the big takeaway from this chart is no matter which station we're at, upstream or downstream, they're all exceeding our standard. So the standard is not a direct apples to apples comparison. We're sampling for phosphate, which is a portion of total phosphorus, and our target is set for total phosphorus. But even despite us only sampling a fraction of total phosphorus, we're still exceeding by quite a bit our phosphorus standard. And so, you know, unfortunately, it's probably linked to legacy sediment nutrients, and then we also have a lot of likely what we call illicit discharges. So we have places where our sanitary waste system connects to our storm sewer system, and nutrients and bacteria can leach from that waste system into our storm water system, which gets out into the creek, is most likely our major contributor. That, as well as with over 51% residential sites, we probably have a lot of fertilizer applications and just stormwater runoff related nutrients that contribute to this high phosphorus. Another way to look at our data, so that last chart was looking at it spatially from upstream to downstream. This is just looking at general annual trends. So looking at each site, each year, are we seeing phosphorus go up, go down over the time? Are we seeing any trends from one station to another? It looks like in 2018, which if I recall correctly, we had quite a lot of rain, but not a lot of, we had quite a lot of rain. Whereas in 2019, we had a lot of rain events, but they were mostly smaller rain events. And so I've been doing this program for 2 years, so it's interesting to see that in 2018, levels were a lot higher than they were in 2019. And I think that had to do with a lot of really big spring events in 2018. So we go out every time we get a rain event over 2 inches in Euclid Creek, and we just check on erosion down at Wildwood because we did a big restoration project there. And I went out in 2018 quite a few times to do that. So we were having these big over 2-inch rain events in 2018 pretty frequently, whereas in 2019 we didn't have a single 2-inch rain event. And so I think anecdotally, probably 2018 was higher because of all those larger rain events, especially in the spring. We find that phosphorus that's attached to the sediment, if we get those big rain events early in the year, then that's those years when we're more likely to get algae blooms if it's combined with warm weather. So next is our nitrogen data or our ammonia data. So very similar, no real spatial trends, just like with phosphorus. So it's a fun chart, but sometimes, you know, we graph something and it just doesn't show us anything. And so this graph, you know, for what it's worth, it's okay. We look at it. Again, not apples to apples comparison. So that target is for nitrate, whereas we're actually sampling ammonia. The good news is ammonia in Euclid Creek is generally pretty low. We don't typically have any major issues. So if a volunteer was to take a sample of this and we were to see a high reading, that's when we would flag Ohio EPA and say, hey, our monitors noticed something odd. Can you go out and verify that? You know, this could be an issue for fish. So our volunteer data is nice because it can be a trigger for us to get someone out to take more state standardized testing if needed. Again, just looking at our ammonia data annually versus spatially. And with any volunteer data, you know, you've always got to do quality control, quality assurance checks. And we do have a couple high values out there that might just be a data entry issue. So it's hard to say without knowing what happened on that day. That's why we really like our volunteers to keep notes on how the weather was that day. Was it raining while they were out? Did they notice that the stream was a lot more dirty than it normally is? Those kind of verbal narrative information can help us decide if a value is actually legitimate or if it's maybe just an error in data entry. This is our total suspended solids data, and so this is a logarithmic chart, so you'll see that it increases in factors of 10. And so most of our data for Euclid Creek is usually really clear. Most of our data is falling in that less than 10 milligrams per liter, but we do occasionally get these really high spikes. And usually, like I said, that's going to be in response to either someone was doing some sort of construction project and not using protections, or maybe it was a big rain event and we had a lot of erosion that contributed to total suspended solids in the stream. Like I was talking about earlier, some of these really high values, we just would want to check those and make sure that those correspond to a rain event, or that there was notes that, yeah, it was really muddy that day. And so that's something that recently we've had better quality assurance, quality control, but some of the older data we still have to look into. Our conductivity monitoring data, same thing, no real trends other than, what we do notice is that with a lot of these parameters from Acacia, which is taken above the park, to our next station, which is below the park at the SEL library, we notice that there's a little bit of a drop. And so we think that Acacia is really doing a nice job of filtering pollutants. The station is just downstream of a mall, so we'll get all of the runoff from that parking lot. We have a lot of litter problems there. And then we're noticing that, especially with the nutrients, that they tend to go down. So that's a good sign. And same thing here in general, is that we kind of see a little bit of a drop. And with conductivity, we've been testing for that since 2006. And the reason is to get at the salt in the stream. So this isn't a direct measurement of salt, but it relates to it. And so we can use this data to predict what the salt was at that time. And what we've noticed recently when we started doing salinity data, which I'll show you next, is that there's really high salinity at that Acacia station. And so this is just downstream of the mall, it's just downstream of Cedar Road. And we've just noticed that those values are really high. And we know that certain communities are really good at keeping their roads clean during the winter, but that also may mean that they're applying a lot of salt, which the stream has a hard time handling. We've noticed just in general that conductivity does seem to be going up. And that would make sense with what other people are noticing with salt and freshwater not being able to take care of it as much. That said, some of these values are a little questionable. We're guessing this one with the question marks is probably a data entry area. With our monitor, which we'll talk about after the data discussion, we have different units, and if a volunteer accidentally enters the wrong unit, that can make the data look wrong. So salinity, this is a new test for us, so we just got a new probe that does salinity as well as conductivity. And so we don't really have a great data set yet. So this is just from October through December. And so basically, 3 months worth of data for each station if we're lucky. But I thought it would be cool to compare that to the targets that we're looking for in freshwater versus saltwater. And basically, for freshwater, we want to see between 0 to 500 parts per million. And, not surprisingly, during these winter months when salt was being applied, we are exceeding those targets that we would like to see. So we'll have to keep an eye on this data over time, make sure our monitors are using the right protocols and that these new Pocket Pros are actually, doing what we expect. So we'll probably do some tests of known values in the future and just make sure that our monitors are doing what we think they should. Our dissolved oxygen monitoring, Euclid Creek seems to most of the time have really good dissolved oxygen. Here we would just be looking for if there was values below those red lines. And so those red lines are the minimum targets that we want to see for dissolved oxygen. So we want to see more than 5 milligrams per liter dissolved oxygen in our freshwater creeks in Ohio. And most of the time we're good there, but occasionally we have had those values dip below that at Acacia and at Wildwood. And so, when those values were recorded, we would have reached out to Ohio EPA and tried to figure out what was going on at that time. All right, so that's the data. We're still working on looking at that and looking at different ways to analyze it. Mary Ann, who is doing her project, did a really cool presentation for our water quality monitors a couple of weeks ago, and she had mapped she had put it on the map, and so it was really cool. So you would see each time she sampled, it would show in red, green, or orange, depending on the parameter, if they were low, high, or medium. And it was kind of neat to see that visual representation on a map and see if maybe there was any spatial trends. So maybe we'll be able to do that in the future with our volunteer monitoring data. It's something that we don't have our college partner anymore, and so we're having to do the analysis and reports in-house and take care of all the equipment. So some of the stuff that we'd like to be doing, we're working on getting the program up to date so we can do that as well. So next, I'm going to talk about our equipment and our protocols. We're very fortunate that even though we just lost our partnership with Tri-C, they were taking care of our equipment. They were basically organizing all our volunteer coordination to pick up our kits to go out and monitor. Now we're doing that in-house. So we lost that partner, but we're very fortunate to have Cleveland Metro Parks as a partner. They have what's called their Watershed volunteer program, and they coordinate volunteers all over Northeast Ohio to get out and do projects like volunteer water quality monitoring. And so they were able to get a grant to get a third kit. So now we have 3 kits that volunteers can check out to go and do this monitoring. And so at this time, 2 of our kits are housed at the North Chagrin Nature Center at North Chagrin Reservation. And during the summer months, we're going to put our third kit out at Wildwood Marina. So it'll be really convenient for our monitors to go and pick up. So we're very fortunate to be partnering with them. And as part of that, we are working with them to streamline the water quality volunteer monitoring programs between each watershed. So in Northeast Ohio, we have several different watersheds that are doing volunteer water quality monitoring data, and we all do things a little differently, or we do have different monitors or different equipment. And so we're working with them to streamline that. And so now, as of this spring, Euclid Creek water quality monitors and Rocky River water quality monitors, as well as Cahoon Creek water quality monitors, will all have the same equipment. Some of us are testing slightly different parameters, but at least now we'll all be on the same equipment. And so we're working with the volunteer monitoring program to do that. And part of that update is we're trying to turn our program into 21st century programs. So in the past, we were using those paper data forms, and then we would enter that manually into our Excel sheet. So now we have moved to an online data entry form on Google Forms, where our monitors can enter that data into the form, and it's instantly being added to our database, which is great. And then obviously with QA/QC, so that's something new. Our new kit storage location. So in the past, monitors would go to Tri-C East and pick up our kits, and now they're going to pick them up at North Chagrin Nature Center or at Wildwood Marina. And so with that, I'm going to talk just a little bit about the different equipment we use and show you our procedure manual. I will be providing the manual and a video that we made for our Rocky River watershed volunteers. So you can actually see how the monitoring gets done. I'm stuck at home right now, obviously, and so just like you guys. And so for now, we're gonna let you look at that video to actually see how the kits are used. I don't have a kit here with me in-house, but I'll walk you through these slides just to talk about the different equipment. And then if you have follow-up questions or want more information, I'll provide some stuff to your professor, and she can share those with you, and you can feel free to reach out if you have questions. So with that, we'll talk a little bit just about what our monitors would do when they go out. So the first thing they would do as monitors is go out. They have in their kit these directions that are up on the right side of the screen, and they would open things up, start doing their data entry. And the first thing we always do is use a sediment stick to look at the clarity of the water. This, in Euclid Creek, it's actually redundant, so we're doing the sediment stick test, and then we're actually using a colorimeter as well to test for total suspended solids. But I think what's nice about using the turbidity stick or the turbidity tube for citizen science is that it's a visual connection to what you're testing. So when you're using the colorimeter, you're popping it in, and maybe you don't fully understand what the test is doing, but with the sediment stick, you're looking in the tube and you're connecting that, oh, okay, this much water I can see through, and I can see that dot, and it's up. Yeah, this is clear water, or oh, this is really dirty water. I really had to empty a lot out of the tube before I got a reading. So the turbidity stick is a nice way to communicate water quality and clarity to volunteers. And so in Euclid Creek, we use both the turbidity tube and we use a colorimeter test to do this. In Rocky River, they just use the turbidity tube. And so for our colorimeter tests, so just kind of walking you through the equipment that we use out in the field. We've got the turbidity stick, and then we have we just updated to a Hawk DR900 colorimeter. So these are really expensive equipment, but they basically we're trying to get pretty good level quality of data and how they work. And so for each of these tests, we have a sheet similar to the one on the right that walks our volunteers through step by step. So they don't have to remember when they go out, oh, which program do I hit to do total suspended solids? Which program do I use for ammonia? And so basically it'll step by step walk them through everything from good sample collection, so rinsing your sample cups 3 times, all the way to wiping your sample cell, and how to put your sample cell in the colorimeter, read it. All of those things are laid out step by step for our monitors. So we do 3 tests with the hot colorimeter kit. We use the total suspended solids test. We do nitrogen, which for Euclid Creek, we use ammonia. It's a little bit longer of a test than nitrate is, which is what Rocky River looks at. With the ammonia test, you've got to do 2 different reactions to get the color changes that you want to see, and you have to do that in both your sample cell and your sample cell and your blank cell. And so it's a bit of a long test. It takes about 15 minutes. So with our monitors, once they're trained and they've been out and they've gone in the stream, what we'll tell them is while they're doing this test and while the timer is running, that they can do some of the other tests. So with phosphorus, similar, using the colorimeter, using a reagent packet to get that color test to show how much phosphorus is in the water. Next, we use, and this is a new equipment for Euclid Creek, so we're now using a YSI dissolved oxygen probe. This one has a little more calibration involved than the probe we were using in the past, so we're getting used to that. We need to go out every month or so and change out the membrane on that. And so it's got a little bit of maintenance involved, but it's a really simple way. It's basically just probe, you just stick it in the water, let it sit there for about 5 minutes while it reaches equilibrium, and that reads out temperature and the dissolved oxygen as well as atmospheric pressure. And then our last probe, in the past with Euclid Creek, we used to have 2 probes. We had one for conductivity and one for pH. And so we've recently moved to this Hawk Pocket Probe Plus tester, which tests conductivity, pH, total dissolved solids, salinity, and temperature, all on one little meter. And we try to get out at least once a month to calibrate that as well. And so that's something that when we had our partnership with Tri-C, these were getting calibrated every time before a volunteer went out. Now, we have to, get staff out there to calibrate. So we hope to get out at least once a month, maybe twice a month, to calibrate these for all of our different kits. So with Euclid Creek, we have 3 kits. With Rocky River, I think they have 6 or 7 kits. So it's a lot of calibration work, and maybe an opportunity to partner with schools again to help with calibration and learn more about our program. So with that, I would recommend you watch the video that I'm going to share with the Rocky River water quality monitoring process. Very similar to Euclid Creek, but it's going to walk you through testing for nitrate instead of ammonia. We're always available at Cuyahoga Soil and Water Conservation District if you have questions about watersheds, about stormwater, just how to do cool volunteer opportunities like this with citizen science. So please reach out, let me know. I'll share some more information. With Euclid Creek Watershed, all of the information about our volunteer monitoring programs, so the data monitoring protocols, the data sheets, how to sign out the kit. All of that stuff is available on our website, euclidcreekwatershed.org. I really appreciate you taking the time to learn about our water quality monitoring program, and please reach out if you have any follow-up questions. Thanks. Have a great day.